Okay, this video is going to cover the first 10 questions of practice exam 2. So that is it if you're not sure which exam we're working here. So I'm going to do the first 10 and I'll continue to do videos from this practice exam until we get it completed. All right, number 1. We want to integrate 0 to 8 of x to the 2/3 dx. Okay, so let's add 1 to the exponent, so that's going to be x to the 5/3, but we're going to need a 3/5 out front, and we're going to evaluate that from 0 to 8. So that's going to be 3/5 times 8 to the 5/3 minus 3/5 times 0 to the 5/3. Okay, so I can cross out this part. All right, the cube root of 8 is 2. 2 to the 5th is 32. So that's 3/5 times 32, which is going to be 96 over 5. So that is B. All right, I think that one's really doable. I hope you get some questions like that on the AP exam in May. All right, let's do number 2. Number 2 says, what is the limit as x approaches 0 of 2 minus 2 cosine x over x? Okay, so this is going to give you 0 over 0 if you plug the 0 in. So that's indeterminate form. What you want to do is use L'Hopital's rule. Okay, so we usually will do something like that to indicate that we're doing L'Hopital's rule. It doesn't matter on the multiple choice part whether you put that or not. But what you do is you take the derivative of the top and the derivative of the bottom and then see if you can plug 0 in and get an answer. So if we do that, the derivative of 2 minus 2 cosine x, the derivative of cosine, is minus sine. So that would be positive 2 sine x. And the derivative of x is just going to be 1. So let's plug in 0 to that. That'll be 2 times the sine of 0 over 1. The sine of 0 is 0. So that is 0, and that is answer B. Okay, so L'Hopital's rule really makes finding limits pretty quick work. All right, number 3. What is the limit as x approaches -2? And we have a piecewise function here. You've got absolute value of x minus 1 if x is greater than -2, and 2x plus 7 if x is less than or equal to -2. All right, so what you want to do is just plug -2 into each part. If they are equal, then the limit as you approach -2 from the left and the right are both equal, then the limit exists. Okay, so let's plug in -2. That'd be absolute value of -2 minus 1, which is the absolute value of -3, which is 3. And then for the bottom part of the piecewise function, that'll be 2 times -2 plus 7, which is also 3. So since those two are equal, the limit exists, and it's 3, and that is answer C. All right, so I hope so far, 1 through 3, that you feel like these questions are pretty doable. Okay, let's look at number 4. Number 4, we've got a graph of f prime. Okay, so A, B, and it looks something like that. Okay, so what is this telling you about f of x? Well, it's telling you since between A and B, the derivative is positive. Okay, the derivative is positive. F prime is greater than 0 from A to B. Only goes below 0 to the left of A and to the right of B. What that means is that f is increasing from A to B. So let's take a look at our graphs, our answers, and see which graphs, if you're going left to right, between A and B, is it increasing? And the only one where that is true is graph D. Okay, graph D, see how it's decreasing till it gets to A, and then it increases between A and B, and then it decreases after B, which is what this graph of the derivative is telling you. Okay, so that's how, that's one that if you know what you're doing, you can just get that one really fast. Okay, I'll just pause just a second if you're still writing on that one. Okay, let's look at number 5. Number 5, we want to integrate from pi over 2 to x of 2 cosine t dt. All right, well, don't worry about the x there at the top. We're just going to plug x in. So let's take the antiderivative of this. Okay, that's going to be 2 sine t. Okay, the derivative of sine is cosine, so 2 sine t, and we'll evaluate that from pi over 2 to x. So that's going to be 2 sine x, just plug in x for t, minus 2 times the sine of pi over 2. Well, what's the sine of pi over 2? Sine of pi over 2 is 1, so that's going to be 2 sine x minus 2 times 1. So 2 sine x minus 2. Looking at the options, that is D. All right, not too bad. Number 6 is one of those. So the first 5 were pretty quick work. You could really get those. You have, remember, on this part of the test, 2 minutes per problem, and you could absolutely get all 5 of those in way less than 2 minutes. Number 6 is one of those probably going to take you more than 2 minutes. All right, and that's okay if you've made good time on 1 through 5. Okay, number 6 says, given the equation y is equal to 3e to the minus 2x, what is an equation of the normal line to the graph at x is equal to natural log 2? Okay, so we got to remember that the normal slope is equal to the negative reciprocal to the tangent slope. So if we can find the tangent line slope at x equals natural log 2 and then flip it and negate it, we'll have the normal slope, and from there we should be able to pick the right answer. So to get a slope, you're going to take a derivative, right? So y prime is equal to 3e to the minus 2x times the derivative of negative 2x. So that's negative 2. So y prime is equal to 6e to to the minus 2x. We need to plug in the point natural log 2 to get the slope. All right, so our slope is equal to 6e to the minus 2 times the natural log of 2. So here's where you need to know the properties of logarithms in order to try to figure this out. So that's going to be, let's rewrite this as 6e natural log 2, and then we can bring that coefficient up top here to minus 2. Remember, e and natural log cancel. Okay, so that's the same as 6 times 2 to the minus 2. 2 to the minus 2 is a fourth. So that's going to be 6 over 4, which is 3 halves. Okay, 3 halves. All right, so that is going to be, oh, by the way, this is, I'm sorry about that. That's not minus 3. It's just going to be 3e to the minus 2x times negative 2. So that'd be a minus 6, minus 6, minus 6, minus 6, minus 6. So minus 3 halves. So I apologize for that. I'll give you a second to fix all that. Okay, so the tangent slope is minus 3 halves, so the normal slope is equal to positive 2/3. So looking at the equation, you can see that the slope of positive 2/3 is A and B are your only possibilities, so C and D are out. All right, so that helps narrow it down. So our equation of our normal line, y minus y1, okay, y minus y1, is equal to the slope m times x minus x1. All right, we know that x1 is natural log 2. And we know that the slope is 2/3. So what is y when x is natural log 2? Okay, so we can just plug that in. Y is equal to 3 times e to the minus 2 times natural log 2. Okay, so that's going to be 3/4. Okay, if you bring that negative 2 and make it 2, it would be 3 times 1/4, which is 3/4. So it would be y minus 3/4 is equal to 2/3 times x minus natural log 2. So we would move that 3/4 to the other side, make it positive, and that's going to be a. You probably could have picked it to be a without even trying to figure out that y is 3/4, because you're going to need an x minus natural log 2, and they put plus in part B. So that one is quite a bit of work, and you have to be careful. I made a mistake and forgot to carry that negative down, and realize that kind of halfway through. So, but that's okay. If that one takes 3 or 4 minutes for you to do, that's fine. You built up some time in 1 through 5. All right, take just a second. I'll get out of the way here so you can write it down. All right. But to me, even though 6 took a while, it's worth doing. Any problem that you know how to do is worth your time, because you're going to get some that you don't know how to do. All right, number 7 uses the definition of the derivative. And there are just some problems, you know, we did this way back in chapter 2 at the beginning. There are just some problems that to me aren't worth the time. Okay, so the answer to number 7 is B. If you would like to go through that, look at your notes at the beginning of chapter 2 and where it talks about using the definition of the derivative. But I don't think that this one is worth spending a lot of time on. So let's skip number 7 and go to number 8. So number 8 says if f of x is an antiderivative of x squared times the square root of x cubed plus 1 and f of 2 is equal to 0, then what is f of 0? So this is going to be another one that's going to take us a little bit of time. To get f of x, we're going to have to take the antiderivative of x squared, and I'm going to rewrite x cubed plus 1 to the 1/2 power. All right, so we know that f of x is equal to that. And our initial condition is f of 2 is equal to 0. So we're going to have to use that to get c. All right, well, this is u substitution. Let's let u be x cubed plus 1. du is going to be 3x squared dx. 1/3 du is equal to x squared dx. So we can rewrite this integral 1/3 out front, and then I would have u to the 1/2 du. So that's going to be 1/3. All right, then you're gonna make that u to the 3/2 when you add 1. So you have to put a 2/3 out front, u to the 3/2. So that's going to be 2/9 u to the 3/2 plus c, which is 2/9 x cubed plus 1 to the 3/2 plus c. Okay, so we have our initial, we know that f of 2 is equal to 0. So I'm going to plug those numbers in now, all right? 0 is equal to 2/9 times 2, our x value, this is x, this is y, 2/9 times 2 cubed plus 1 to the 3/2 plus c. All right, just plug the initial condition in so we can solve for c. So we would have 0 is equal to 2 cubed is 8, so 2/9 times 9 to the 3/2 plus c. The square root of 9 is 3. 3 cubed is 27, not 9. 3 cubed is 27. 27 divided by 9 is 3, so you would have 0 is equal to 6 plus c. So that means c is equal to -6. Right, no calculator on this part. Okay, I may be getting too low on the board for you to be able to see on the video, so I'm going to pull that back up here. So we'll have our function f of x is equal to 2/9 times x cubed plus 1 to the 3/2 minus 6. All right, so finally we got to the point where we can try to plug this in. What is f of 0? So we'll plug 0 in. F of 0 will be 2/9 times 1 to the 3/2 minus 6. That's going to be 2/9 minus 6. Okay, let's pull this up here. That's 2/9 minus 54/9, which is going to be minus 52/9. All right, that one was quite a workout. And that's D. But again, you've banked some time in 1 through 5. You guys know how to do number 8. You've done these types of problems before. So go ahead and spend the time to work it, because odds are in some of your future problems, you're going to be able to do some of those in 15, 20 seconds and get that time back. All right. Plus, you kind of skipped number 7 and just took a guess. All right, 2 more from this video. Number 9 says if a function f is continuous for all values of x, which of the following statements are always true? Okay, and number 1 we have 2 times the integral from a to b of f of x dx is equal to double that, 2a to 2b on your limits of integration f of x dx. And we don't have an identity for that. I mean, you could try to plug some numbers in, you know, go through that, but we just don't have, that's just not true. All right, let's look at part 2. So what you're looking for are ones that you know are true, that you have had to use before. So it says a to b of f of x dx, is that equal to b to a? So we're going to flip the limits of integration of minus f of x dx. And we've worked a couple of these before. That one is absolutely true. If you flip the limits of integration, it negates the function. So that part is true. That's very useful for the fundamental theorem of calculus part 2 problems. And then part 3, the absolute value of the whole thing, okay? A to b of f of x dx. So if you take the absolute value of that whole thing, is that the same as the absolute value of just the inner function dx? Okay, so this one is always going to make it positive, the whole thing. This one won't always give you a positive answer, because when you subtract, one of these limits may be bigger than the other one. So that's not true. Certainly don't have an identity for that. So the answer is 2 only, which is C. Right, so that's one, if you knew how to do it, it'll go pretty quick and you'll make some of that time back up. Okay, number 10 says the graph of f is shown below. It says f is twice differentiable. Okay, so that just means you can take the second derivative. So it's always decreasing. And here we are at 0. So it says, which of the following has the largest value? F of 0, well, we know that f of 0 is equal to 0. Okay, you can just look at the graph. When x is 0, y is 0. How about f prime of 0? Well, f prime of 0 is the slope of the tangent line at 0. The slope of the tangent line at 0 is negative. Okay, so we know that f of 0 is bigger than f prime of 0. How about f double prime of 0? Well, this graph is concave down. Okay, so it's also going to be negative. The second derivative is negative if the graph is concave down. So that means if f prime of 0 is negative, f double prime of 0 is negative, then the largest value is just f of 0. And so that is A. So that completes the video for the first 10 on practice exam 2. I hope that as we went through that, you feel pretty good about it, that you could probably get most of those. Maybe you could get at least 6 or 7 of those, and we'll continue on with the next video. I'll try to do number 11 through 20.